Hello and welcome back. Hello, years 5 and 6 lesson. And I can see that lots of people are joining up and having a little chat discreetly and not revealing any personal details, which is exactly what we have asked you to do to keep safe before we start. And you're absolutely right, should be starting soon, and I am here now. So I can see we've got some new names, so welcome new people. And I can see we've got some names as well who have been here before. So I think that school has started again now. So you may be having work from school as well. So I do leave little tasks for you to do. They come through in the chat and we do email them to your grown-ups as well. So you've got some work from us, but I absolutely understand if you have lots of work from school, that's got to take a priority. And if you're joining us just to have that interaction of a feeling of being in a real classroom, in a live classroom, then that's absolutely fine. So we will start today by going through the problems that we sent you at the end of last lesson. So if you have done them, that's brilliant. If you haven't, don't worry about it. You can just have a go at them now as we go through. But can you give me a thumbs up, one of your lovely emojis to say, yes, I did. Hello, Miss Nikki. Hello, lovely pupils. Just to say, did you manage to do the task that was set? Just let me know if you did. So that just gives me an idea and some feedback. So for people who've joined us before, you will know this, but for the lovely new people who have joined us today, great to see so many new people. This is a maths lesson. It is a real maths lesson. So the same thing goes as if you were in class. Once the lesson starts, which it has now, then we must keep focused. Oh, lovely smileys coming through. Keep focused on the maths lesson. It's not a place for chitter chatter. And unfortunately, we have had to remove a few people who have wanted to start other conversations going during the lesson. So this is a real lesson and we need total focus on the problem and the maths. So please be warned, if you do go off track, then our moderator will take you out of the lesson. Okay, so just show me you know that you are ready to start the lesson. Show me a lovely emoji. I'm here, I'm good to start. Oh, nice, little figure, little like a ghosty figure. Nice to see you. Hello, and we are ready. I'm here. Hi. Nice thumbs up. Hi, yep, two. Lovely. Okay, brilliant. So we are good to go. So I'm going to drop the screen down and show you a little problem. When I hold it up, it goes out of focus, so it's easier for me to drop down. This is one of the problems that we set you to have a little think about in between the lessons. Okay, so Rexy's just going to hold that paper clearly for us there. Okay, so this is about working out factor pairs, and I know you would have done these at school. But it's so important for us to have these at the tip of our brains, absolutely ready to come back and be totally ready to be used very quickly. So this is Annie's method. This is one method of finding factor pairs. So she goes through the numbers until she gets up to 6 times 6. Then she will know she has found all the factor pairs. Okay, when she gets up to that squared number, that's 6 times 6, which is what it is for 36, she will know that she has found all the factor pairs. And she's gone through and she's put a cross by a number that does not have a factor pair for 36, because 7 5s are 35. So we're certainly not going to get another group of 5 out until we get to 36. Now you're saying you can't see, so I wonder if I can lift that up a little bit. Don't know quite now. Maybe it is easier if I have it up here. Let me come back up. Maybe the writing's just a little bit too small, so I'll just hold that there, okay, to make sure that you can see. Okay, so this is Annie's method of finding the factor pairs to 36. Okay, is that better? Okay. That's Annie's method of using the factor pairs to 36. Okay. I'd like you to use that same method and find the factor pairs to 64. Can you find the factor pairs to 64? So let's write that up on the screen. Find the factor pairs to 64. Okay, now you can use the same method, so we can go down here, draw a table with 2 columns. Remember, the columns are the vertical, and then we can put our rows in. And let's go down until we hit that square number, 1, 2, 3, 4, etc. Go down the numbers until you get to a square number, so you know that the factor pairs are then going to be just reverses of what you've done already. How many factor pairs can you find to 64? How many factor pairs can you find to 64? Okay. Now 11 is not a factor of 64 because 6 11s are 66. Okay. So I'm going to say 1 goes into 64. 2 will be 32. Will 3 go into 64, etc. Keep going down. Keep going down until you get to a square number. Until you get to a square number. Keep going down. Does 3 go into 64? Or is that a cross? Does 4 go into 64? Or is that a cross? Have a think. What factor pairs have you found? Okay, 5, 6. Keep going down. 4 and 16 I've got. Okay. 3 won't go, will it? 3 into 64 won't go. 3 20s are 64. 3 21s are 63. We haven't got another group of 3 to make. Now 3 is a cross. Absolutely agree with you. 3 is a cross. 1 and 64, 2 and 32. Not 3 and 16. 32, 48. 58 that comes to. 4 and 16, 2 and 32. 5, does 5 go into 64? Is 64 in the 5 times table? Is 5 a multiple of 64? Well, all multiples of 5 end in 0 or 5, don't they? So we know that's not. No. 6 go into 64. Does 6, oh, somebody's got down to the square number, the factor pair. So we know that's when we're going to end. We're going to end 8. So we're seeing, does 64, is it divisible by 6? Is 64 divisible by 6? Is 64 in the 6 times table? Well, 10 6s are 60, 11 6s are 66. So no. 7 7s are 49, 8 7s are 56, 9 7s are 63. So no, that's not going to either. So our factor pairs for 64 are 1 and 64, 2 and 32, 4 and 16, 8 and 8. Okay, so really, really simple way of helping us to make sure that we do not miss out on any of our factors. So we do not miss out on any of our factors. Okay, let's have a look at this question. Let's have a look at this question. An even number has an even number of factors. Is that true? Is that always true? Is that always true that an even number always has an even number of factors? Is that always true? An even number always has an even number of factors. If it's not true, can you give me an example where it's not true? Does an even number always have an even number of factors? Does an even number always have an even number of factors? If you think it's not true, then prove it. Give me an even number that does not have an even number of factors. Okay, some people saying it's true, some people saying it's not. Can you try 36 for me? Can you try 36 for me? Let's have a little look at what factor pairs we can find in 36. Okay, so 1 and 36, 2 and what? 2 and what? 2 and 18, 3 and, does 3 go into 36? Should do. 3 and 12, 4 8 are 32, 8 4s are 32, 9 4s are 36, 5, no it does not, 6 times 6. Let's have a look what we got there. Even number always has. Let's have a look. 1 and 36, 2 and 18. What have we got there? We missed any out? 5 and 12. 5 and 12 doesn't go to 36, does it? 5 12 is 60. 4 and 9. So let's see what we've got. We've got 1 number, 2 numbers, 3 numbers, 4 numbers, 5 numbers, 6 numbers, 7 numbers, 8 numbers, 9 numbers, because that's the same. So that has got 9 factors. So no, an even number does not always have an even number of factors. Okay, it does not always have an even number of factors. It does not always have an even number of factors. So look at this for me then. The bigger the number, the more factors it has. The bigger the number, the more factors it has. Is that true or false? The bigger the number, the more factors it has. The bigger the number, the more factors it has. The bigger the number, the more factors it has. Is that true? The bigger the number, the more factors it has. How many factors does 12 have? How many factors does 12 have? How many factors does 13 have? What do we know about 13? What sort of special number is 13? What sort of special number is 13? Ahaha, well done. What sort of special number is 13? Somebody's already mentioned it. Yeah. If we think about 13 and other numbers like it, 13 is a prime number. So although 13 is bigger than 12, it only has 2 factors, itself and 1. So it only has itself and 1, whereas 12 has 1 and 12, 2 and 6, 3 and 4, 5, no, not 5, not 6, not 7, 2 and 6. 12 has 6 factors. 13 has 2, and 13 is bigger. So that is false, because we have to think about prime numbers. We have to think about prime numbers. Let's think about another problem. I am thinking about a 2-digit number. Okay, I am thinking about a 2-digit number. I'm thinking about a 2-digit number. 2-digit number. That's what I'm thinking about. Okay, big question mark. I am thinking about 2. I'm thinking about 2-digit numbers, actually. Sorry. I'm thinking about 2-digit numbers. Okay, so what could they be? What could they be? I'm thinking about 2-digit numbers. Both of them have a digit total of 6. So when you add their 2-digit numbers, it comes to 6. So digit total of 6. Okay. They have, let me use a different color pen for this so it stands out. They have common factors. Okay. So they have common factors. They have common factors of 1, 2, 3, 4, 6, and 12. Okay, so there are our clues. I'm thinking about 2-digit numbers. There's one of them. There's the other one. They have a digit total of 6. So like 51 has a digit total of 6, 5 and 1, 3 and 2, 32 have a 3 and 3, 33 have a total digit of 6. Okay, they're not the numbers. They're just randomly explaining what a total digit of 6. Okay, a total digit of 6. These are the common factors. 1, 2, 3, 4, 6, and 12. They are the common factors. 1, 2, 3, 4, 6, and 12. What 2 numbers can they be? So you need to think of numbers with digit totals to 6. Think about what they could be. And then ask yourself, What common factors? Or you might think, I already know a number that's got those common factors, 1, 2, 3, 4, 6, and 12. I can already think about those. Okay, so have a little think. Oh, somebody's come straight in. Did you do that today? Or don't worry if you're lagging, that's okay. So people who came in straight away, just give me a clue about your thinking. Explain your thinking to me. People have come in with 2 numbers and they have come in with the right answer. Well done. Can you tell me your thinking? Just type something in to give me an idea of what the thinking was in your head. Just give me an idea what the thinking was in your head. Just really, really interested to see what thinking process you went through. What thinking process did you go through? Because they came really, really quickly. And I am very interested to know what thinking you went through. What thinking did you go through? Yeah, also somebody refreshed and they are back with us. So that's brilliant. That's brilliant. What thinking? They all have 1. Yeah, they all have 1. Everything has 1. One is a multiple of all of the numbers, all whole numbers. Yeah. So I would think to myself, okay, let's go through the 12 times table. I would start with the biggest factor. Let's have a look, 60 and 12, because 60 is a factor of 6 and also 24. So you knew that. Okay. I would think to myself, well, let's look at the biggest factor, 12. If they've all got 12 in them, let's look at 12. And I would go through the 12 times table. So I think 12. Okay, yeah, that's a factor, but the 2 digits don't add up to 6. 24. Oh, 2 and 6. Oh, okay, that one does. So 24. Okay, 24. 36, they don't add up to 6. 3 and 6 is 9. Okay, 48. 4 and 8 is 12. That doesn't give 6. Okay, 60. 6 and 0. Okay, that's what I would have done. I would have gone through the 12 times table to help me. Does anybody else have that? I'm lagging. Don't worry, don't worry, don't worry. If you're lagging, you will catch up. Try to refresh your page if you are lagging. Try to refresh your page. So let's have a little look at using those times tables to help us, okay? So I've got some friends who are going to come to my party, okay? I've got some friends who are going to come to my party. Let's have a little look, because let's do some of those tables that don't always stick in our head quite as well. So let's have a look. I've got this number of friends coming to my party. This number of friends are coming to my party. Use your knowledge. Okay, there are 7 friends there. Use your knowledge of the 7 times table to tell me, if I have 49 grapes, how many will they get each? And then write for me the multiplication equation and the division equation that tells the story of that. Okay, there are 7 friends. I have 49 grapes. How many will they get each? Write the multiplication and the division equation that tells that story, please. 49 grapes. How many each? Write the multiplication and division equations for me, please. 7 times 7 is 49. What's the division equation, please? 49 grapes, how many each? I want both equations. 49 divided by 7. Yet some of you have not got the division symbol, but can use the forward slash. That's like a fraction, so you can do that. So let me know, how many of these did you get? Did you get both of those equations? Did you get both of those equations? Let me move that up a little bit so that you can see. Did you get? Tell me whether you got 1 or 2. Say 1 or 2. Show me which ones you got. Okay. Show me which ones you got. Did you get both of them? Did you get both of them? Yep, 2. I got 2. I got 2. I can see that. Get 2 ticks. Fantastic. So 7 times 7 is 49. Okay. I want each of my 7 friends. I want each of my 7 friends to have 9 sweeties to take home. How many sweets will I need to have? I want each of my 7 friends to have 9 sweeties to take home. How many will I need to have? Write the multiplication and the division, please. Write the multiplication and the division. I want each of my friends to have 9 sweets each. How many will I need to have? How many will I need to have? Write the multiplication and the division. Write the multiplication and the division. I want both equations written, please. I want each of my friends to have 9 sweets each. How many will I need? Write the multiplication and the division. I want to see both of them. Okay, so you're telling me how many I need. Exactly. So 9 times 7 is 63. If I want each of these to have 7, each of these to have 9, 63 divided by 7 will give 9 each. Okay, let's stay on our 7 times table. Okay, I have got lots and lots of tiny, very, very tiny little sweeties to give out, and I want each of my friends to have 280 little sweeties each. I want them to have 280 little sweeties each. How many will I need? How many will I need if I want them to have 280 each? How many will I need? How many will I need? How many will I need if I want them to have 280 each? I want them to have 280 each. Okay, how many will I need? How many will I need if I want them to have 280 each? How many will I need? Let me have a look. Oh, I've got some answers coming in. I've got some answers coming in. How many will I need? How many will I need? Oh, I've got some answers coming in. Let's have a look. Well done. Well done. So I want the multiplication and the division equations, please. I want the multiplication and division equations, please. I want the multiplication and division equations, please. So 7 times 280 is 1,960. 1,960, thank you, divided by 280 is 7. Okay, so let's see. Exactly. Let's see. So let's have a little think. That was a little bit of a brain teaser. Let's change the number of friends I've got now. Okay, you have to bunch up a little bit. My house has not got enough room for you all to have that much distance. So we've got 9. We've got 9 friends now. I want my friends to have 8 sweets each. Can you please write the multiplication and division equations for them to have 8 sweets each? The multiplication and division equations for them to have 8 sweets each. Multiplication and division equations to have 8 sweets each. Multiplication and division. Okay, let me have a little look. Oh, well done. Well done. They are coming in straight away. So the multiplication, there are 9 friends. If they're going to have 8 each, I will need to have 72 sweets, because 72 shared by 9 friends will give 8 each. Okay, will give 8 each, because I want the multiplication and the division. Now you're getting the idea. Let's see if we can be a bit quicker this time. I'm going to give you another problem. It's still for those. Oh, let's have 8. You got to go home. Okay, then bye. Bye, thank you for coming. You're welcome. Take your sweeties with you. Okay, I did. So now I've got 8 friends. Okay. And I want to give my friends 7 cherry tomatoes each. 7 cherry tomatoes each. Write the multiplication and division. Write the multiplication and division for 7 cherry tomatoes each. Multiplication and division. Okay, multiplication and division. Well done, they're coming in. They're coming in. Okay, I want the multiplication and division. Try and do them both together. So we're really reinforcing the relationship between them. Really reinforcing the relationship between them. Multiplication and division. Oh, totally focused. Absolutely amazing. Brilliant. Okay. See if you can try and resist the urge to enter before you put them both in. Okay, so the multiplication and division. I wanted them to have 7 cherry tomatoes each. There's 8 friends. 8 plus 7 is 56, because 56 divided by 8 gives 7 each. 56 divided by 8 gives 7 each. Oh, what's that, Mummy? What's that? I can have more friends. Oh, thank you, Mummy. You're so kind. That's a lot of friends to have over. You'll have to prepare lots of things now, Mummy. I know, I know. So I now have 12 friends over. This is a good party. I've got 12 friends over, okay? And I am making my party bags. And in my party bags, I am going to give each of those friends 6 little lollies. How many lollies will I need to have? Multiplication and corresponding division equation, please. Okay, multiplication and division equations, please. 6 lollies each. 6 lollies each. 6 lollies each. Here we go. 6 lollies each. There's my friends. Okay, and my mum's going to give them strict instructions not to eat the lollies altogether. And they're all made from natural fruits, just to be clear. 6 lollies each. Oh, look at that. Put my little label down the bottom. Friends, you're taking up so much room. Can I bunch you up a little bit? Yeah, you know each other really well, and we don't have to social distance. We're okay. We're okay. We can do that. Okay, 6 lollies each. I can see the multiplication and division sums are coming in very carefully. Where is mine? Okay, so there were 12 friends, and they needed 6 each. That comes to 72. The corresponding division is 72 divided by 12 will give 6 each. Okay, will give 6 each. That's the corresponding division. The corresponding division will be 6 each. Okay, so I have still got these 12 friends here. I have still got these 12 friends. And what we are going to give them now is we're going to give them a fitness. We're going to give them a fitness workout. So each of my friends is going to run 30 meters. 30 meters. How long is the race? Each of my friends is going to run 30 meters. How long is the race? Give me the multiplication and division equations that explain that story. So I could have asked, the race is this long, my 12 friends ran equal sections to work it out. How? Give me both the multiplication and division. Give me the multiplication and division. And I want the units, please. Do not forget the units. Okay, multiplication and division. Oh, they're coming in really quickly. Well done. They are coming in very, very quickly. Now, after this, I'm going to give you some multiplication problems to do. So we have warmed up very nicely, and we're going to have a multiplication problem to finish us off. Right, let's have a little look. So each friend ran 30 meters. 12 times 30 is 360. Okay, so somebody said they didn't understand. Each friend had to run 30 meters. There are 12 friends. So 12 times 30 meters is 360 meters. Now the division corresponding, there were 360 meters run by 12 people. They each ran 30 meters each. Okay, they each ran 30 meters each. Thank you, friends. Hey, you were good at those multiplication and division questions. We got some really good focus and we got really good pace of learning. I am really excited. Woo-hoo-hoo-hoo. Okay, let's now have a little look at some other questions. I gave you one of these questions last lesson, but we didn't get to finish any more. We've just got a little bit of time to finish off now. I'm just going to fold them over so we can just focus on one question. Yes, a question about you, Rexy. It's a question about you, Rexy. So let's drop down. Rexy's having a read. Maybe you'll get it. Let's have a little look. Okay. There's the question. Rexy is allowed 1 walk a day. The park he has walked in has a track that measures 800 meters. He has walked around it 4 times. How long is his park walk? How long is his park walk? Okay, so let's just do this bit first of all. Just hide that second bit. Okay, Rexy is allowed 1 walk a day. He's just confirming that that is true. The park he has walked in has a track that measures 800 meters. He has walked around it 4 times. How long is his park walk? How long? Show me the multiplication equation, please. Don't just give me the answer. Show me your thinking. Show me your thinking. Show me your thinking. And I want units of measure as well, please. Okay, so well done. Yes, thank you very much. Well done if you have shown this. I know in a previous lesson, one of the pupils said, oh, why can't you tell us well done when we've done it? I can't mention you by name, okay? I'm just trying to keep you safe. So what I do is I ask you to give yourselves ticks and to send me lovely emojis so I can be really clear. Okay, so 4 times 800 is 320. Oh, Miss Nikki, come on, meters. Or you could have made it into kilometers. You could have converted by dividing by 100 and said, okay, it's 3.2 kilometers. So that's how long his walk was. How many laps will he need to do to have been taken? How many laps will he need to have been taken around to have covered 10 kilometers? How many laps will we have to go around so that he has covered 10 kilometers? Okay. Each lap is 800. Each lap is 800 meters. How many laps will we need to have gone around until we have covered 10 kilometers? How many will we have gone around until we have covered 10 kilometers? Now think about using your maths that you know already, okay? So when I look at this, I think, well, 10 laps, 10 times 800 would give me 8,000 meters. That's what I would think. And then I think, right, I've got 2 meters or 2,000 meters to play with. That's what I would think. I would break it up into that. I would say 10 times 800 is 8,000. I've now got 2,000 more. Right, okay, now I can look at my 8 times table, 8, 16, 24. So actually I need another 3 laps, which would give me 2,400. Then I know if I'm going to add those together, I've got 8,000 and 2,000, that's 10,000. That would give me 10,400 kilometers. So if I've done 12 laps, then I know that I have gone over the 10,000 meters, or 10.4 kilometers. So I have got to go around, I've got to go around 12 will give me that much. So I've got to go around, 13, 3. That's going to get me under 13 laps. Yeah, because I did 3 8 so 24. So add in my 3. Okay, 13 laps. I would have gone over then, wouldn't I? I would have gone over, but I would have covered my laps. I would have done that and I would have covered my laps. Okay. So thinking carefully, okay, using the maths that you know already. Okay, so our lesson has finished today. We're going to have some more problem solving. You've been an amazing group today. I have to get my flashing lights, and they are so well deserved. You are my model class. You have had such brilliant maths focus today. Doing those equations was just absolutely amazing. I'm so impressed. I am so impressed by how you swapped those multiplication and divisions and found the relationships with them. I am so, so impressed. Thank you for joining us today. You have been so totally focused on the maths that it's just been such a pleasure to be with you and see your thinking unravel and see all those lovely thoughts. Thank you very much for joining us. We will see you on Thursday. We'll do some more problem solving. We'll do some division by hundreds and thousands to make sure we've got those multiplying up by powers of 10 and dividing down. And next week, I'm thinking of focusing on fractions. So it'd be really helpful for me if you say, oh, Miss Nikki, can we think about this, this, and this? These are the things I struggle with, or I'd like to have some more help with. So we will start with fractions, and then we will move into percentages and decimals. But I would really like to hear, thank you for joining us. You've been amazing. It can only be a good lesson if I have good students, and I've had amazing students. So can you have a little think and tell your grown-ups, or even put in the chat for me, what you'd like us to think about with fractions, decimals, and percentages next week. We might not get on to percentages and decimals next week, but we certainly will by the week after, because we're going to go through fractions and just absolutely check our understanding on those. So give me some feedback. Let me know what you'd like to have some help on, anything that you're struggling with, and make sure that you put that in the chat, or you get your grown-ups to let me know, so I really know what's best for us to spend our time focusing on. So you can see in the chat that the problem for today is up, and we will start Thursday's lesson by going through that. Remember, do not worry if you have got work from school and it's too much. We will go through it together. But thank you for a lovely lesson. Thank you for joining, and I look forward to being with you on Thursday and joining with you on Thursday and having a lovely time again. Please tell your friends and family. Make sure that your grown-ups share the links for Thursday so we get as many followers as possible. Well done, everybody. That was brilliant. Well done.